Okay, students, hello. This is an explanation on how to solve this exercise. It says, find the slope of the tangent line to the parabola y equals 4x minus x squared at the point 1, comma 3. Then we have to find the equation of the tangent line and then graph both functions. So, let's start. So the first thing that we need to analyze is the degree of this function. So the original function, the degree is 2. So this is a second degree function. So the graph will be a parabola that is opening downwards. If we calculate the derivative, we are going to find that the derivative will be a straight line, an equation of a straight line. So we need to calculate that equation as well. So the first thing that we need to do, step number 1, is to calculate y prime, or it could be f prime of x, and that for that we're going to use the definition. So the definition says limit when h is approaching 0 of, let me draw here a straight line, f of a plus h. So that means for every x we're going to plug in or substitute an a plus h. So this will be 4 times a plus h minus a plus h squared. So we are done with the first part of the definition. Then we're going to subtract the second part of the definition that says f of a. So for every x, we're going to write a. So this will be 4a minus a, let me do that again, a squared. Everything is divided by h. So the second step will be multiplying each of the terms so we can get the polynomial on top of the fraction. So this will be limit when h is approaching 0. We always write this limit. Let me draw another straight line here. So we are going to apply our distributive property for all of these terms. So this will be 4a plus 4h minus, this is a square of a sum, so this will be a squared. Let me do that exponent again. A squared minus 2 times ah minus h squared. And then we just change all of the signs after this negative sign. So we write everything outside the parentheses. So this will be minus 4a plus a squared divided by h. So as we said in the class, we're going to cancel all of the terms that doesn't have an h, since we need to factorize or factor out an h so we can cancel the denominator. And we are also canceling a squared and this a squared. So we have to check that every of these terms have h so we can factor out this letter so we can cancel out with the denominator. So the next step, limit when h is approaching 0. Let me draw again, straight line. So I'm going to factor out this h from this term and from this term, and from this term. So I'm left with a number 4 minus 2a minus h. This is what we are looking for, to cancel out this h. So now we can evaluate the limit. So the limit is going to be an existing number. It is not undefined, now it is an existing number. So we can use our limit laws. So the limit when h is approaching 0 of a constant, that will be a constant, minus 2 times a limit when h is approaching 0 of a. So we are going to plug in this 0 on this a, so this term is going to cancel out, minus, sorry, no, this will be a, I'm sorry, this is the term where we are going to substitute our limit. So we are going to plug in this 0 here, so this is going to cancel out. And then we are left with 4 minus 2a. This is the derivative in terms of a, but we are looking the derivative in terms of x, because this function is in terms of x. So the derivative will be 4 minus 2x. So now this is the answer. This is the answer for the derivative. So the derivative, as we said in class, is a family of all of the slopes from this function. So now we need to find that specific slope, of which point when x is equals 1. So the next step will be calculate the slope at this point here, at 1. So we are going to plug in, if my point is 1, 3, we are going to plug in the value of the x of the point in our derivative. So that is read as f prime of x. So this is the derivative. Now we're finding f prime of 1. So in the derivative, we're going to plug in this number. Okay? So it will be 4 minus 2 times 1, that is equal to 4 minus 2, 2. So now this number indicates the slope of this line. So we have a slope, we have a point. For the third step, we are going to use my point slope form. So we need to find the equation using this point slope, because we have a point, we have a slope. So which is the point? Y minus y1 is equal to m times x minus x1. Here I'm going to plug in y minus 3 is equal to m, that is 2, times x minus 1. So this is the equation of the line in the point slope form. We're going to convert this point slope form into my standard form of the equation of a line. So we are going to solve for y. So y minus 3 is equal to 2x minus 2, y is equal to 2x minus 2 plus 3. So the equation of this tangent line is equal to 2x plus 1. Okay? So this is the equation of the tangent line. Equation of the tangent line at x equals 1. Now, let's see the graph. So, how can I do this graph? You know how to graph this parabola, and you know also how to graph this line. So, as we said, this is a parabola that is opening downwards, and this is an ascending straight line because my slope is positive. So we're going to try to graph or sketch the graph, and then we're going to see the real graph. So you must know how to graph this function. So let's try to do a sketch. So this is opening downwards, and how can I calculate the x-crosses? So for the x-crosses, that is when y is equals to 0. So if we use the original function, 0 is equal to 4x minus x squared. Now we can factor out a common factor, so it will be x times 4 minus x equals 0. So the first cross will be at 0. 0, comma 0, that is the origin. So right now it is crossing here. Now let's find the other cross. So it will be 4 minus x equals 0. So x is equal to positive 4. So if this is 0, for example, this will be 4. And this is the origin, right? So my graph is going to do something like this. So this is just a sketch of a graph, okay? Crossing this point. And then we're going to locate this point, the given point, that is 1, 3, that it will be over here. And our tangent line will cross at 1. So it will cross over here. And then it will be tangent to this point. So I'm going to try to draw. Let me do it again. This is my first time using this tool, so please. Okay, so this is our tangent line, and it is tangent to this point. So I think I could do it better on paper. This is my first time using this tool, so this is a sketch. So now we found the equation of the tangent line, and we draw both functions. In case you want to see which is the exact representation of this graphs, I used this program so we can see them. It is pretty close. So this is only a sketch, this is a real graph. So this is my point, this is my tangent line that I found, and this is the original function. So this is how you find, and this is how you solve this problem. Thanks for watching, and I'm going to continue with the next exercises. Goodbye.